Hello there, Mr. Sutton here with the Pre-Cal Honors 5-8 Extra Practice Number 2 solutions on simple trigonometric equations. For this problem, we're trying to solve this trig equation for all angles between 0 and 360. We'll start by isolating the sine function by dividing both sides by 10. So we have sine equals -7/10. And at this point, it's nice noting that we've got a negative sine value. So that means that our angles are going to be below the x-axis because sine is talking about the y value of the angle. So that means we're going to be in quadrants 3 and 4, below the x-axis. So let's go ahead and find the angle that our calculator is going to give us now. We get that by doing sine inverse of both sides. So sine inverse of -7/10. And doing that on the calculator is going to give us a value of about -44.4 degrees. So that's the initial value from our calculator. We need to get a reference angle out of this now to actually find these answers in the other quadrants. So if I'm going down 44.4 degrees from the x-axis, that's what this means, then that means my reference angle is going to be 44.4 because that's how far I am from the x-axis. And to get the quadrant 3 version of our answer now, we need to start at the 180 line and go forward 44.4 degrees, so we have to add that to 180. That's going to be 224.4 degrees. And to get the quadrant 4 answer, we have to start at 360 degrees and go backwards 44.4 from the x-axis there. So 360 minus 44.4, which is going to be, let's see, 315.6 degrees. On this problem, we're trying to solve this cosine trig equation for angles between 0 and 360. Let's start by isolating cosine. So if we add 1 over here, that's going to be -1. Dividing by 2, we have cosine equals -1/2. And at this point, we note that cosine has a negative value. That means that cosine, which is talking about the x value of the angle, our angle itself has to be to the left of the y-axis, where x is negative. So that's going to be quadrants 2 and 3. So now let's go ahead and take inverse cosine of this equation and figure out what our initial answer is going to be. So plugging this in the calculator, that's going to come out to about 120 degrees, actually exactly 120 degrees. Turns out that was one of our special angles, special values. So we need to get a reference angle out of this to be able to get both of these angles. Reference angle, 120 degrees is 60 degrees from the closest x-axis angle of 180. So we have a reference angle of 60 degrees then, if we subtract that from 180. So in order to get our answers, quadrant 2, we actually already have a quadrant 2 answer, that's 120. For quadrant 3, we need to go 60 degrees past the x-axis. So past 180, 180 plus 60 degrees takes us into the third quadrant, down from the x-axis. That's going to be 240 degrees. For this problem, we're trying to solve this trig equation for answers between 0 and 360. Let's start by isolating my tan function here. I can do that by dividing both sides by 5. So we have tan of theta equals 6/5. Now, before we do anything else, let's note that this is a positive value. That means that tangent, the slope of my angle, is positive, which means my angles must be in the quadrants where I get positive slopes. So going up and to the right, that's going to be quadrants 3 and 1 and 3. So to figure out what these answers are, we have to take inverse tan now of both sides of this equation. So that ends up giving us theta equals inverse tan of 6/5, which we will need the calculator to figure out. So doing this out on the calculator, we end up with about 50.2 degrees. So now let's get a reference angle out of this. 50.2, that's between 0 and 90, so that actually is a reference angle. So we've already got that. Now we can proceed to figuring out the answers in quadrants 1 and 3. For quadrant 1, we've actually already got a quadrant 1 angle, 50.2 degrees. So that's also one of our answers. We're getting a lot out of this calculator-based answer. For quadrant 3, we have to go 50.2 away from the x-axis into the quadrant 3 direction. So you're starting at 180 and basically going down 50.2 degrees, which means you're adding 50.2 to 180 to keep going around that circle. So that's going to be 230 0.2 degrees for that one. To solve this trig equation, I'm going to start by isolating the cosecant function. I can do that by subtracting 32 and dividing by 3. So we have cosecant theta equals negative 32 divided by 3. And now there's no cosecant button on your calculator, so we're going to turn this into one of the original 3 trig functions. This is actually the reciprocal of sine, so I can rewrite cosecant as sine as long as I take the reciprocal of the other side of the equation. So I can then rewrite this as sine of theta equals negative 3 over 32. And it's worth noting that this is a negative number. Since sine is the y value of your angle, if that's negative, we are below the x-axis, which means our angles are going to have to be in quadrants 3 and 4. So let's do sine inverse now of negative 32 and figure out what our starting point is. So plugging that into our calculator, we're going to end up with about negative 5.4 degrees. Now we need a reference angle to actually figure out all these different angles in these quadrants here. If you're negative 5.4 degrees in the fourth quadrant, you're 5.4 degrees away from the x-axis. So 5.4 is your reference angle. So now we need to get our quadrant 3 and 4 answers out of this. For quadrant 3, we have to go 5.4 degrees away from the x-axis in the quadrant 3 direction. So that's going to be 180 plus 5.4. And that's going to be 185.4 degrees. For quadrant 4, you're going backwards 5.4 from 360, so subtracting it, and that's going to be 354.6 degrees. To solve this one, I need to get secant of theta by itself. To make that a little bit easier, since I've got all these fractions going on, I'm just going to multiply by my denominator of 5. So that's going to give me 15 minus secant of theta equals 13. That's a little bit easier to deal with. And then I can just subtract 15 and divide by negative 1. So that's going to give me secant equals positive 2. Now, in order to keep going, I need to turn this into one of the original 3 trig functions. So I'm going to take the reciprocal of secant, which is cosine, and then that's going to equal the reciprocal of 2, which is 1 over 2. If cosine is 1/2, the first thing to note here is that that's a positive number. That means my x value of my angle must be positive, which means I must be to the right of the y-axis. So that means my answers are going to be in quadrants 1 and 4. To get any of these answers, we need to do inverse cosine of this equation. So cosine inverse of 1/2 is going to give us some kind of answer. We don't know if it's one of these answers, but we'll take what we get here. So this is one you could do on the calculator, or you might remember that the cosine of 60 degrees is 1/2. Either way, 60 degrees is what our calculator would give us for an answer there. Now that we've got an initial answer, we need to get a reference angle to help us get these other answers. Now 60, as it turns out, is already a reference angle. It's already telling you how far your initial angle was from the x-axis. So since this is your reference angle, we can use it to get these answers. For quadrant 1, well, 60 degrees is a quadrant 1 answer, so we've actually already got that one more or less for free. Quadrant 4, we have to go 60 degrees away from the x-axis in the quadrant 4 direction. So you're starting at the 360 line and going backwards 60 degrees. 360 minus 60 is going to give us 300 degrees. To get to the bottom of this equation, I have to first isolate the tan function. So to do that, let me add 4 to both sides. That's going to be negative 1.1 over there. And then if I divide both sides by negative 2, that's going to be, let's see here, 1.1 over 2 is going to be 0.55. So that's what tan of theta has a value of. Now, since this is a positive number, that means the slope of my angle, the tangent of the angle, is positive. So that means I'm in the quadrants where I'm going up and to the right if I draw an angle. So quadrants 1 and 3. So let's go ahead now and figure out a calculator angle and see what that looks like in quadrants 1 and 3. So to do this, I need to take the tan inverse of both sides. Theta equals tan inverse of 0.55. That's what I'm going to do on my calculator now. And at this point, it's worth noting that although they're asking for my answer in radians, I'm actually going to do this in my calculator in degrees mode, because all the things I do are much easier in degrees. I'm just going to convert to radians at the very end. So this is a degrees answer right here. we initially get, well, that's interesting. Oops, I need to do tan inverse. There we go. Tan inverse of 0.55. All right, this is where it helps if you know what kind of answer you're expecting. Something was definitely wrong with that other answer. But yes, 28.8 degrees now, because we were in degrees mode when we did that. So now I need to get a reference angle and use that to figure out my quadrant 1 and 3 answers. 28.8 actually is a reference angle because it's between 0 and 90. It tells you the distance from the x-axis. So using that to get my answers, quadrant 1 is going to be 28.8 degrees. That is, again, between 0 and 90. And then for quadrant 3, we need to do 28.8 into the third quadrant. So we're going to start at the 180 line and add 28.8 to that. So that's going to give us 208.8 degrees. But we're not quite done. We have to turn these into radians. So to do that, we multiply each of these answers by pi over 180. So let's do that with 28.8. I'm going to need the calculator for this. So 28.8 times pi over 180, that's going to give me 0.50 if I round that off to the nearest hundredth. And let me do the same thing with 208.8. Multiplying that by pi over 180 on the calculator, that comes out to about 3.64. So those are my two answers in radians.